Let's understand the step 2 of the business object oriented modeling, which is the discovery step. The discovery phase of the project is the one that takes up most of a product manager's time. The objective of requirements analysis, which peaks during this phase, is to discover and document the requirements of the proposed system. The central product of this step, the completed PRD, acts as a contract between the business and the developers. If a requirement is not in the PRD or equivalent documentation, it's not part of the contract. So it's essential to ensure that you document all necessary requirements completely, correctly, and unambiguously. Now you must be wondering, this sounds very rigid and not aligned with the agile methodology. And you are right. Different life cycles have their own different constraints, and that is why this PRD might be very rigid, or this contract of PRD might be very rigid, or it might be very, very loose. So for example, in a typical client uh, in a typical client setup where you have committed something to the clients, the PRD that will come out of that requirement would be very, very rigid, that we have to build this out because this is exactly what the client has asked for and we have committed for, right? As against that, in a new age technology startup, like let's say a Flipkart or let's say an Uber, the requirements are evolving and they are being discovered as we go through. And in that case, the PRD is a little more flexible, right? And it can be anywhere between extremely rigid to extremely flexible, extremely flexible to the extent that nobody actually sits down and writes it and rather just uses user stories. uh, I have seen the spectrum from both the ends, right? And that also depends on the team that is working on it. If it's a smaller team, if it's a larger team, if there is external team involved, if there is internal team involved, and so on. But but to put all of this in context, essentially just make sure that you are considering the life cycle that you have chosen, the team that you have chosen, and the product and the dynamics that you have chosen, brewed very well with the flexibility that you are expecting in the PRD. In certain teams, you need things to be very rigid. In certain teams, you can be comfortable being a little more flexible as well. Okay. So just to highlight this, on all waterfall projects, requirements analysis activities described earlier are performed during the discovery phase, since they must be complete before development may begin in the construction phase. On iterative projects, analysis peaks during the discovery phase but continues during the development phase as well, since not all requirements are gathered upfront with this approach, right? As well, on such projects, that is the agile or the iterative projects, a phase typically consists of a number of iterations, each incorporating a complete cycle of analysis, design, coding, and testing for the use case scenarios selected for that iteration. Finally, for iterative projects that follow an agile approach, the requirements are not baselined unless they are being implemented. So the first step in the discovery phase is performing a behavioral analysis, which basically sums up to storyboarding the entire user's experience and lifecycle requirements for the key business objects. Okay. So how do you describe system use case, right? How do you perform behavioral analysis? The first step is describing the system use cases, right? So at the end of the initiation phase, you identified system use cases in the PRD, right? And this version was baseline for step 2, which is the discovery phase. By baselining the PRD, you ensure that you have a reference point to go back to. Updates to the PRD during the discovery phase are made on a new working version, right? So for your first changes, review the list of system use cases. If needs have changed or you have obtained further information, update the system use case diagrams and related text in the PRD. Once you have settled on a list of system use cases, your next step is to investigate and document each one thoroughly, right? So what are the deliverables of this step 2A1, which is of describing the use cases? This step produces a number of deliverables like the PRD template contains a section for system use case diagram. These diagrams are updated. Okay. If you remember, just a quick recall, the PRD template refers to the template that I have shared in the unit in the part one of this unit. Also, the PRD has a section called system use case descriptions. Right? For each system use case that appears in the system use case diagrams, a use case description is added that includes a completed use case description template. The text documentation may be augmented with any of the following. So you can have activity diagrams, decision tables, decision trees, or any other supplementary documentation. If you have not heard of these terms, don't worry because I'll be covering them very soon. So the what are the use case description templates? I've given a reference of this template. Please have a look by yourself. Uh, the UML, which is the baseline or which is the base framework on which this unit is based. So the UML as such doesn't have a lot to say about text or how to describe it and how a use case should be described and so on. And that's why there's this template that I'm sharing. It fills that gap by incorporating industry best practices. If you're working for an organization that doesn't have a template, use this as your starting point, but customize it as time goes on. If you already have a template, compare it to the following template. You may find features you would like to add. Keep one thing in mind when using this or any other template. Its main value is as a way to institutionalize best practices in your organization. You should customize it as time goes on, based on what works for you. As an example, this template requires the PM to keep detailed rules about field verification out of the use case proper. These rules are documented in class diagrams or in a data dictionary instead. But one organization I have worked with found that it could have get it it couldn't get its developers to cross reference, right? If a rule was not explicitly stated in the use case, the rule wasn't implemented in the software ultimately. Consequently, the organization decided to include such rules in its use cases itself, right? So remember that whatever choices you make, there is only one yardstick. Does it work? Okay. So this treat this as a template, as a guideline, but things may vary and differ for your own organization, and please adapt. What is the fundamental approach behind this template? The underlying principle of this template is to describe workflow using a simple narrative style that avoids complex logic. The trick to keeping things simple is to handle variations in a separate area of the document rather than in one all-encompassing section. First, you document a normal, typical interaction in a section called basic flow. Next, you describe alternative success scenarios in an alternate flows. And finally, you describe error handling in an exceptional flows section. Honestly, exceptional flows is one section that I would love to see whenever in fact, that is one section that I typically look for in an EPRD that I come across because that kind of shows the detail that has gone into designing that PRD. Most often, I see PRDs devoid of that, which leads to a lot of edge cases being completely unhandled in the implementation. Finally, how do you document the basic flow? The basic flow describes the most common way that the use case plays out successfully. Some people call it the happy scenario. It reads as a straightforward narrative. The user does X, the system does Y. As a rule of thumb, the basic flow should not list any conditions, since subsequent sections handle all errors and the alternatives. Right? So you're having separate sections for basic flow and alternative flow and the exceptional flow. So as a rule of thumb, the basic flow should not list any conditions. To keep documentation consistent, employ a style guideline throughout your company for writing use case requirements. So if you have the authority or if you can persuade and influence your organization, then I'll suggest create some sort of a guideline for writing use case requirements. What should be covered? What are people looking for? What are developers looking for? What are testers looking for? What are designers looking for? So that you're covering decent amount of information in the use case so that everybody's on the same page immediately. How do you document the alternate flows? Well, document each scenario not covered in the basic flow as an alternate flow or as an exception flow. An alternate flow is a variation that does not lead to the abandonment of the user goal. I repeat this. An alternate flow is a variation that does not lead to the abandonment of the user goal, while an exception flow involves a non-recoverable error. So like a 404 in a very simple terms. So if your team has trouble deciding whether to list a scenario in the alternate flow or exception flow section, merge the two sections into one and list both types of flow there. Okay. But if you can clearly outline what are the exception flows and what are the alternate flows, please do that. Right. Uh, so just taking the alternate flow documentation a little further, there are a number of issues you will need to clarify for each flow you have identified. These are as follows. So you want to identify the trigger, the event or condition that causes the process to be diverted from the basic flow, divergence point, the point within the basic flow from which the process jumps to the alternate flow, and finally the convergence point, the point at which the process returns to the basic flow. Remember the basic flow, right? It was an alternate flow. There's something triggered the entire diversion of the process. So from the basic flow, the process moved to a separate flow, an alternate flow, which becomes the divergence point. And then finally, there will be a convergence point coming back to the basic flow. And basic flow or happy flow is where you want the user to be. And how do you document exception flows? Well, list each error condition that leads to the abandonment of the user goal in the exception flows section. Typical exception flows include cancellation of a transaction by the user and system errors that force a transaction to be cancelled. Documentation rules are the same as for the alternate flows, except that there is often no convergence point since the goal is abandoned. Right? In that case, the last line of the flow should read, the use case ends in failure. I'll just repeat this entire thing because it's very, very important. So how do you document exception flows? You list each error condition that leads to the abandonment of the user goal in the exception flows. Typical exception flows include cancellation of a transaction by the user and system errors that force a transaction to be cancelled. Documentation rules are the same as for the alternate flows, except that there is often no convergence point since the goal is abandoned. In that case, the last line of the flow should read, the use case ends in failure. Lastly, I want to mention the activity diagrams for system use cases, right? How do you describe these basic alternate and exception flows? So the basic alternate and exception flows do an excellent job of describing a scenarios, right? One at a time. I hope you guys remember, a scenario is one way that a use case can play out. And within that scenario, there are basic alternate and exception flows. If the flows connect to each other in complex ways, add an activity diagram as a supplement to the use case description in order to clarify how all the flows fit together. Remember, whenever things go complex, please use diagrams. Do not rely on text. Even if you have written it, there's a good chance they might be interpreted in wrong ways or in ways that you do not want them to be interpreted. Right? So you draw the diagram using the same conventions you used earlier when modeling the workflow of business use cases. So what are the guidelines for conducting system use case interviews? Well, interviews are pretty much the same. And I covered this in the start of this particular unit. And I'll suggest to refer back to that slide. Uh, but let me just give you a particular scenario of a system use case interview. So you will typically start by asking the interviews to describe the basic flow, that is the happy flow. Then go through the basic flow step by step and ask if there is any other way each step could play out. List each of these as an alternate or exception flow, but don't let the interview veer off into the details of what happens within each of these flows. It's very easy to get lost there, right? So your aim at this point is merely to list the flows. Ask interviewees if there are any alternatives or errors that could happen at any time, as opposed to at a specific step during the basic flow. And add this to the alternate or exception flows. Now that you have a comprehensive list, ask interviews to describe each flow in detail. And finally, go over each of the steps in the alternate and exception flows, asking if there are any other ways those steps could play out. So this sounds very um, common sense and logical. The only thing I'll suggest is make sure that whenever you're doing any kind of research or on an existing system, or when you are interviewing people, try to first document or list down all the things that you would like to cover, right? And that is why I insist on, first of all, making a laundry list of all the flows that are possible in the system that is being researched. Once that has been listed down, then you can go deeper into each one of them. So are use cases all you need? Well, that's something that people do ask me. Uh, so people often ask me if the use cases are all of the requirements, or whether they are all you need to create test cases. Well, it's not. Use cases are just the beginning. Use cases give rise to scenarios, and then scenarios gives rise to different flows, right? So first of all, they are not all of the requirements because they only address the user requirements, right? There are other requirements like security requirements or business requirements or any kind of third party requirements. Secondly, they focus on the flow of the conversation between the system and the actors, the storyboard of the interaction, correct? Other issues such as screen designs and data validation rules are defined in other artifacts that the use case links to, right? To fully document and test a system, you need use cases and these are the artifacts. So use cases are not all that you need, or just writing user stories is not enough, because you have to describe a lot of these things as well. Now, to describe system use cases, uh, a very important construct that you need to understand is decision tables. Okay, there is a link that I have shared in the slide. Please refer that. So use a decision table to describe the system response to a number of interrelated factors. Okay, if each factor can be looked at separately, do not use a decision table. Just use the alternate and exception flows, or alternatively a condition response table. Okay, so for example, the review case report referred to a decision table that describes the logic for validating whether a case is payable and for determining the payment amount. Okay, so let's say you have a small business where you review case reports. Okay, and you sometimes charge for them, you sometimes don't charge for them, right? So you want to create a decision table that describes the logic for validating whether a case is payable and for determining the payment amount. The rules for these steps could have been described in the use case proper, but that would have made the text harder to follow. Instead, the rules are extracted into an accompanying decision table appended to the use case. Right? So describe the use case and then append a decision table to it, and you have made things much more easier to grasp and understand. What is the underlying concept behind this? Instead of explaining the logic that underlies a decision, you simply list every possible situation and document how the system treats it. The method for completing the table ensures that you have accounted for every mathematically possible combination of factors. So when a decision table is useful, use decision tables during the interview process to ensure that you have questioned the interviewee about all possible combination of factors that affect the outcome of a use case. Document decision tables as appendices to system use cases or in an external document. For example, in a business rules folder. During testing, use decision tables to derive test cases that cover all combinations of related factors. Each column of the table represents a test case. Similar to decision tables are decision trees. Okay. So instead of table, you will use a picture to describe the system's behavior. Okay, so medical condition is poor or good. If it's poor, then substance abuse, yes or no, previous rejections, yes or no, and then you can come back to a final answer, right? All of this help you in covering all the underlying flows or underlying mechanics that you need to implement in your product. And what are condition response table? Again, I've given a good reference. uh, So condition response table is similar to decision table, except it's more to do with if else. So if the input conditions contributing to a decision can be evaluated one by one, use a condition response table instead of a decision table. So for example, to prepare taxes, you need to evaluate each condition one by one. And that's a good case for a condition response table. That if this condition is met, this is the response. If this condition is met, this is the response. So what are business rules? Well, other business rules, that is beyond those expressed in decision tables, represent another type of documentation that should be pulled from the use case proper and referred to in a dedicated section. Business rules are rules from the business area that constrain business processes. These rules are documented separately because they would distract from the flow of the use case and because they often apply to more than one system use cases. For example, an airline system might include a rule that the weight of an airplane must never exceed its maximum weight capacity. This rule is active during a number of use cases. For example, check in passenger and load cargo. Rather than restate this rule in every use case that it applies to, list it separately as a business rule and refer to the rule from the use cases. Business rules may be stored in the low tech way. For example, in a book, or it could be simple document, it could be anything. At the other end of the spectrum are rules engines, software that manages and enforces business rules. Either way, it's not enough to record the rules. You must also specify which rules apply to which use cases. This makes it easy to identify which use cases need to be tested when a rule changes. When an automated rules engine is used, there is another advantage to linking use cases to a rule. It is inefficient to have this software at runtime check all business rules for every use case when only some apply, right? What are some advanced use case features that you can actually implement and make your use case a little more uh, use case document a little more comprehensive? So once you have written up some system use cases, you may notice that certain steps appear in more than one use cases. For example, the same steps for obtaining a valid policy may show up in the use cases, query policy, amend policy, and make a claim against a policy. Keep an eye out for cases like this. They represent opportunities for reuse. Reuse is a good thing. It means that you only have to go through the effort of documenting the steps once. It means that if the steps ever change, you will only have to change the documentation in one place. And it means that the steps will be treated consistently throughout the documentation. Often, these inconsistencies arise when, due to a change in requirements, one of the affected use cases is changed but the other is not. So, the UML has provided some advanced use case features to help you increase reuse in the use cases. Use the advanced features for internal documentation. Don't show them to the users. For example, show business stakeholders use case diagrams that include only the basic system use cases discussed up to this point. Dist- Distribute diagrams with the added advanced features to the internal team. Finally, don't go overboard. The addition of an advanced use case feature adds complexity to the model. Use it only when necessary. In some organizations, team can get bogged down in theoretical discussions about whether to use this or that advanced feature. Rather than theoretically working out which feature to use, just write out the system use cases and you are sorted. So the advanced use case features that I'm talking about here, which is include, extend, and generalization, uh, they have an impact on diagrams and on the written documentation. Okay. The purpose of the diagrams is to help the team organize or structure the requirements documentation. The diagrams later serve as a reference. They tell the reader which use case documentation refers to other use case documentation and the nature of the reference. These diagrams are also invaluable when changes are made to the textual documentation of a use case. That is, the diagram clearly points out which other use cases are potentially affected. Some organizations have a bias against use case diagrams as well, especially when they contain advanced features. In my experience, this is often because they don't have a clear understanding of the purpose of the advanced diagramming features, mistakenly assuming, for example, that they are for the benefit of users rather than for organizing documentation. But if your organization is adamant about this issue, use the advanced features only for textual documentation and ignore the diagramming component completely. So, what are these advanced use case features that I'm talking about? Well, there are three: include, extend, and generalization. So, when you're describing the use cases, like I said earlier, you may not need to, there will be instances which are again and again repeated in different use cases, right? So, what you can do is you can just document that the reusable uh, use case or the small use case at one point, and then you can refer it again and again um, at uh, you can refer it again and again in different use cases by using something called include. Okay, so extract the common requirements into a mini use case. The main use cases are set to include this mini use case. This approach is useful whenever a set of steps appear in more than one system use case. Use this feature when a sequence of steps is performed exactly the same way in different use cases. Next is extend. So you leave one main system use case intact and create a new use case that extends the original one. The extending use case contains only the requirements that differ from the original. This approach is useful, for example, for enhanced versions of earlier software releases. And finally, generalization. You create a new generalized use case that contains general rules. Other use cases are created as specializations. They contain the non-generic requirements. This approach is useful when a set of system use cases represents variations on a theme. Let's talk about the next thing, which is describing the state behavior. Till now, we were talking about how do we describe system use cases. Now we are talking about behavior. So once you have understood the use cases that we're talking about, it's important to understand how things and systems are going to behave. So a state machine diagram is a picture that describes the different statuses of an object and the events and conditions that cause an object to pass from one state to another. The diagram describes the life of a single object over a period of time, one that may span several system use cases. For example, a state machine diagram might show the different statuses of an insurance claim: received, validated, under adjustment, adjusted, paid, not paid, and so on. What is a state? Well, a state is a status that an object may have. The object may be in a dormant static state with which it exists once an event it is waiting for finally occurs. An example is the state waiting for receipt of a proposal, which ends once a proposal has been received. Alternatively, an object may be in an active stage, which it exits once activities associated with the state have been completed. An example is the state under adjudication, which ends once adjudication activities have been completed. So, what is state machine? A state machine is a model of the statuses through which an object passes. The model describes the events and conditions that cause it to move from state to state and the activities associated with each state. The model may be depicted as a state machine diagram. The terms state machine and state machine diagram are almost synonymous. The state machine is the behavior and the state machine diagram depicts it. Other names for the diagram are state diagram and state chart diagram, and the diagram was originally developed by David Harrell. So, why draw a state machine diagram? Well, in my experience, I've seen If the states are not very clearly identified and have not been described, then the implementation will definitely have some massive flaws, because something or the other will go amiss. The condition in which the state should work, the and a object can move from one state to another state in numerous ways. And if you have not described all the ways, then there's a good chance that a lot of edge cases can come in which can destroy your entire product. So the behavior of an object over time could be surmised by analyzing system use case descriptions, activity diagrams, and so on. For example, one could gain an understanding of an insurance claim object by noting how it is handled during system use cases of receiving the claim, validating the claim, pay claim. But if the state of the object is critical to the system, it is helpful to be able to get the full picture of the object as it passes through the system. So as you can see in the diagram, there's a clear understanding. This application received, state is pending. Application reviewed, waiting for income verification. Income verified, flagged as possible fraud, then it moves to suspected fraud. And then you can suggest to take a different alternative flow, right? So this is the benefit of using a state machine diagram. It keeps things absolutely clear. Now within the state machine diagram, the first step is to identify states of critical objects. So how do you do this? You define a new state for the object if the system treats the object differently because of a change, or if the object itself behaves differently. If there is no difference, then only a piece of information about the object has changed. You can modify a piece of information about the object by using attributes, right? So some of the examples of states and attributes: red and blue are not two states of a product object but indicates different values of a color attribute. However, sold and unsold may be considered states because they affect how the product is handled. Similarly, this telephone line states. So the telephone line is busy, off the hook, not in use. Invoice has states: entered, paid, unpaid, cancelled. And you can, as you can imagine, you can create multiple states like that. Student registrant states, so which is waitlisted, pre-screened, accepted, attending, graduated, on leave, so many. Next is understanding what are the different types of states that are possible, because different types can behave very differently. So many of the elements that appear on a state machine diagram fall into one of the following categories. So they fall in initial pseudo state. So this is shown as a dot on the diagram. It is the start point for the object. The UML classifies this as well as some other modeling elements as pseudo states rather than states. Pseudo states mark points that transitions may leave from or go to, but they do not represent actual state of the object. Final state, this appears as a bullseye. So you can see a dark circle in the center and a concentric circle at the outside. The final state may be named, and there may be more than one final state for an object. There are a number of restrictions on how you can use the final state. It may not have any outgoing transitions, and you cannot associate specific behaviors such as entry, exit, or ongoing activities. Other states are shown as a rounded rectangle. These typically fall into one of the following categories. Wait state, the object isn't doing anything important, it is simply waiting for an event to happen or a condition to become true. In the credit card example in the figure earlier, the state waiting for income verification is of this type. Ongoing state, that's the second one. The object is performing some ongoing process and stays in this state until some event interrupts the process. For example, a system to manage the work of health inspectors has an inspector state monitoring compliance that ends only when management instructs the inspector to discontinue. And finally, there is a finite state. The object is performing some work that has a definite end. Once the work is over, the object passes out of the state. Once we have identified the states, let's now identify the state transitions. So, a transition may occur automatically when activities taking place while the object was in a previous state have been completed. For example, while an insurance claim is in the state under adjustment, it is evaluated by an adjuster. As soon as the adjuster completes the evaluation, the object automatically transitions out of the state. This type of transition is called a completion transition. Alternatively, a transition may occur because an event interrupts the previous state. For example, an application in the state waiting for income verification stays there indefinitely until it receives the income verified. This type of transition is a labeled transition. How do you depict state transitions? The figure shows a first draft of a diagram showing state transitions for the case object. The example shows a number of elements involved in documenting a transition. So there is something called transition, that is the very first speech box. It's a change of state indicated with a arrow. Then there's event, which is a trigger that fires or forces a transition. To document an event, simply write the event name beside the transition symbol. Transition activity, which is a quick, uninterruptible activity that happens whenever the transition occurs. To document an activity, precede the activity name with a slash, as in slash a sign. That's just one way to indicate. And yes, when you have all of these rules, you can actually you should create a guideline for everybody to follow the same conventions that you're following. Then the send event, so a message that is sent to another object whenever the transition occurs. To document a send event, identify the target, that is the object receiving the request, and the event or message that is sent as follows. So you can have some sign like uh, up up arrow target dot event, right, which can very clearly convey that who is the target and what is the message, right? You can choose whatever convention that fits you, but it's important to have some convention. You can also identify any information or parameters that you need to send to the object. For example, if the convener needs to know the temporary case number, then you can also append that to the case number. And if you find the notation of a send event cumbersome, or in general all of this cumbersome, or if the diagram is to be presented to business stakeholders, don't use this feature, just don't do this. Document it as a regular event and clarify who performs the job with a note if necessary, right? So all of these things are just suggested means. If you can do it, and if that improves on your developers and everybody else likes it, great. Otherwise, follow whatever is best suited for your team and for your setup. Finally, there's a guard condition, a condition that must be true for the transition to occur. That's the guard condition, the constraint that you are proving against. A guard is somewhat like an event in that both determine whether a transition may occur. The difference is that an event forces the previous state to end. A guard is only checked once the previous state has already ended for some other reason, right? And you can use the guard in square brackets, right? So these are some of the popular conventions that are followed. But then again, it assumes that your team members know about these conventions. If they do not know, you can try educating them. If they are willing to adopt your conventions, great. Otherwise, just follow the regular. Just mark the consensus reached and no monitoring with as a guard condition. Just write it in text. An important aspect here is mapping state machine diagrams to system use cases. You can use state machine diagrams to compile a comprehensive picture of how system use cases change the states of objects. To do this, use the names of the system use cases for events and the name of flows for guards. For example, a transition labeled review report with square brackets not payable. So review report not payable with not payable in square brackets means that the transition occurs when the not payable flow of the system use case review report is executed, right? This naming convention can also lead to preconditions and postconditions for the relevant use cases. For example, in figure, the system use case review application is used to name the transition of an application from pending to waiting for income verification. A precondition for this use case is that the application is in the pending state. A post condition is that the application is in the state waiting for income verification. A You can also explicitly document other use case preconditions and post conditions right on the transition label. These look like regular guards but are distinguished by where they appear related to the use case name, right? And you can use the form, or you can use the format precondition use case name slash post condition. So you can append and prepend. So you can prepend the use case name with a precondition and append it with a post condition. So for example, if the transition in figure were labeled valid reviewer has been identified, review application, and request for income sent, right? So the implication is that for the use case review application, the following interpretations apply. The preconditions are that a valid reviewer has been identified and that the application is pending. The post conditions are that a request for income has been sent and the application is waiting for income verification, right? So these are some of the guidelines or some of the best practices that I'm suggesting. You can simply document it. You do not have to use conventions, you do not have to use all of this, but these are essentially good practices, best practices, and this will simplify the way you'll be documenting in your real world uh, a lot. The next thing to identify is the state activities, right? So which is basically once the object has changed its state, what are the activities that occur? So a state activity is a process that occurs while an object is in a certain state. So an activity within a state may take some time. This is in contrast to an activity on a state transition, which always occurs quickly. So transition happens very quickly. The activity that triggers the state transition is typically pretty fast. But once it has entered, the object has entered a certain state, the state activity can take some time. So on entry, whenever the object has moved to a certain state, on its entry there should be something that some activity that can happen, right? So for example, some email should be sent. So when the invoice has changed its state from X to Y, then maybe you need to send notify a bunch of people. So that is an activity on entry. Once it has entered, then another activity could be, once the invoice has changed from X to Y, another activity that you would want to do is, let's say, file for taxes. Then another one, another interesting thing that can happen now is, uh, where the activity occurs in response to an external event. So there was an invoice where it moved from X to Y, and at Y state it was supposed to be paid. So first of all, the customer or the vendor was sent a email on entry of the or change of state of the invoice itself. Another person received it. While he received it, at the same time, the invoice was also accounted for by the CA, by the tax accountant, and they were waiting for the payment to happen. Now there's some activity that occurs in response to an external event. So let's say the invoice has been changed, the deliverables against which the invoice was raised has changed, and so invoice needs to be updated. So that is the activity that can occur in response to an external event. And finally, the exit. So the customer has now paid the invoice and the exit has happened, right? So each one of them can have its own unique activity. Each stage of this: entry, do, event name, and exit, right? As before, if you find the notation of a send event cumbersome, just don't use it. Document it as a regular event and clarify who performs the job with a note. Okay. Now, an important thing here is identifying composite states, right? If a number of states share one or more transitions, you can simplify the drawing by using composite states. So, for example, in progress is a composite state because in progress means that there are a lot of things that are happening internally, right? So you have abstracted everything out. So in progress basically means the access is being checked, you're getting the input, you're checking the balance, and then finally you are either canceling it or you're doing something else. Next is identifying concurrent states. So if according to one criterion, an object can be in one of a state of states and according to another criterion can be in another state at the same time, use concurrent states to model the object. In figure, the claim object moves from the accepted state into the concurrent states if the amount of the claim is large. In this case, the vertical bar indicates a fork, a point after which the following transition occur in any order: a transition to payments scheduled and a transition to monitored. Once all payments have been completed, the case makes the transition out of the payments scheduled state. When the monitoring period is over, it makes the transition out of the monitor state as well. When both these transitions have occurred, that is indicated by the second vertical bar or a join on the right side, the object moves into the payment issued state. On the other hand, if the amount of an accepted payment is small, it immediately goes into the payment issued state. This is a simple example to introduce the concept of concurrent states. Concurrent states can get much more complicated. For example, each half of the diagram typically depicts a series of state transitions, right? So this was all about the behavioral part of it. Let's understand some structural analysis, which is basically you are gathering across the board business rules with class diagrams. So what is structural analysis? Well, in earlier topic, lifestyle requirements for key business objects, you worked with state machine diagrams. You looked at state machine diagrams together with activity diagrams because those are your main options for describing the dynamic nature of the business, the sequencing of business events and activities. If you want to highlight activities, use case diagrams. If you want to shine the spotlight on a specific object and how it changes in response to conditions and events, use the state machine diagram. The state machine diagram started you thinking about it helped you initiate the thinking about the dynamic nature of business objects. Objects are the fundamental atoms that make up a business system. So in this topic, you will learn how to analyze the static structural nature of business objects, the rules that apply irrespective of time. So what is the structural model? A structural model is an abstract representation of what the system is. It represents the aspects of a system that are not related to time, such as the kinds of subjects tracked by the system, how these subjects are related to each other, and the information and business rules that relate to one each other. The main diagram you will be using for structural modeling is the class diagram. FAQs about some of the FAQs about structured analysis. So you might be wondering why the product manager should bother with structured modeling when business stakeholders are primarily concerned with what they can do with the system. So an issue that is addressed in the behavioral model. So in this section, we will look at these and other frequently asked questions. So why isn't the product manager's job over after behavioral analysis? I mean, we are done. Why are we doing class diagrams and structural diagrams? Well, the dynamic behavioral requirements lack a complete description of the nouns of the business. Also, the precise numerical relationship between the nouns is undefined. So, for example, consider a municipality with a human resources system. Because they had not worked out the numerical relationship between employees and unions, they ended up purchasing an HR system that allowed an employee to belong to only one union when in fact some employees belong to more than one. As a result, the software could make only a single deduction of union dues for each paycheck. The data tables were set up incorrectly, and the input screens used to assign employees to unions were incorrect. Guess who had to pay for all these corrections? The municipality, right? Had the PMs performed a proper structural analysis, they would have included the employee union rule in the requirements documentation, diminishing the chances that it would be missed in the software and ensuring that at the very least the cost of the fix would be borne by the developers. So aren't these issues addressed in the behavioral analysis? Well, it is true that many of these issues are contained within the system use case descriptions. For example, in a banking system, the relationship between customers and accounts might be found in an open new account system use case. However, because behavioral analysis does not include a rigorous approach to examining the nouns, it is likely that some important requirements will be missed. Also, because these rules are dispersed throughout the use cases, There is a possibility for internal inconsistency within the PRD. For example, a system use case open new account might allow up to 3 people to co-own an account, while a system use case query account activity allows for only one owner. In addition, future requirements for enhancements to the system may add new inconsistencies. There are some more FAQs which I have mentioned in the speaker notes. I'll recommend that please go through it by yourself. So how do you do structural analysis? You start by identifying entity classes. An entity class is a category of business objects tracked by the system. We'll come on each one of them. Rules about objects and classes. That is the next thing you identify, which is all objects of the same class must share the same operations, methods, and attributes. Right? Then there are some other FAQs which I have mentioned in the speaker notes. I'll recommend that you please go through the speaker notes directly. Right? Plus, have a look at the figure that I've shared. I think that should clarify. Um, that should clarify the entity classes and the different objects types that are there. Once you have all these classes in place, then you should group them into packages. If the model contains a large number of classes, it's worth grouping them so they will be easier to manage. And the UML technically provides the package symbol to stand for a container. We have seen this before with respect to use cases, right? You remember use case packages? Here we will use the packages to contain classes and class diagrams. Class packages may contain other packages for as many levels as necessary. It's helpful to depict all of the packages on a single diagram, a single form of the class diagram. When using a modeling tool such as, let's say, rational rows, there are a lot of modeling tools available as well. It is a good practice to make this the top level main diagram. Using this way, the diagram acts as a navigation map. Each package icon links to the class diagram that depicts all of the classes in the package. There is no rule, although there are suggestions for how to group the classes into packages. One recommended approach applicable to many business contexts is to define packages according to the common flavors of the business classes. So, people and organizations, product and services, and even transactions. How does the package diagram look like? The best way to organize a diagram is to use the package diagram to show only classes, their attributes, and operations, and nothing else. Show relationship between the classes on separate diagrams. An exception may be made for generalization relationships, which are often shown on the package diagram itself. Don't try to say too much on only one diagram. Instead, draw a new diagram to highlight a specific aspect of the system, such as a particular inheritance hierarchy. This way, each diagram gets across one main idea, making it easy to interpret. So you can see package diagrams for a telecommunication company, how product and services can be bundled into uh, digital cell phone and call return. So why is it worth pausing to do some structural modeling when stakeholders introduce new terms? Well, for example, I once worked on the model for a credit lending system. My contacts in the company kept talking about product groups. It was only after I began to develop the structural model that it became apparent that there was no consensus on the meaning of the business term. Half the people on the project thought it referred to a group of products and services marketed together under one package price. Others thought it referred to a particular telephone line and all the services attached to it. This type of ambiguity often crops up in the requirements and can lead to serious errors in the software. By creating a structural model, you will ensure that there is a clear understanding of each business noun that appears in the requirements. So, what are the interview questions for finding classes? The first step of structural modeling is to identify the classes of objects that comprise the business. These may be found through a review of existing documentation. For example, if you have that, please use that. For example, by searching for business nouns in the use case model and through direct interview questions. To discover candidate classes, ask the stakeholders what people and organizations does the system keep track of. Examples include customer, cardholder, board member, and so on. What events and transactions does the system keep a record of? An example is a sale event. What products and services does the system keep a record of? Examples are, for instance, checking accounts and check returns. So check returns is a service, and checking accounts is a product. I have added some challenge questions as well in the speaker notes. I'll suggest that you go through that, right? And just remember that the goal of this step is to produce a simple list of classes, nothing else. Anything else you pick up at this stage is gravy. For example, if you pick up any attributes now, by all means record them, but don't spend too much time on them. Here are some follow-up questions that you can ask users about selected classes. So for example, you can ask them, could you provide a brief description of the class? Could you provide a couple of examples of the class? Could you tell me a few pieces of information, that is attributes, that you would track about each example, that is object? How do you support the class documentation? I suggest that you document the following for each class, that is use a class name, use a description, use examples, give sample attributes, and also give an alias. How do you model generalizations? Well, the subtypes allow you to model business objects that share something in common but have other distinguishing characteristics. What is subtyping? Well, subtyping is where you create a smaller category within a larger category. Useful because it allows the PM to make statements about general types that automatically apply to all subtypes. What is full-time subtypes? If objects cannot change from one subtype to another over their lifetime, that is full-time. And part-time is if objects can change from subtype to subtype during their lifespan, right? So let me just go deeper into this. Uh, so subtypes will allow you to model business objects that share something in common, right? And like I said, subtyping is a smaller category within a larger category. So what are full-time subtypes? A general category can be split into a number of full-time subtypes if objects cannot change from one to another. For example, in a non-co-ed dormitory where dormers are processed differently according to their sex or gender, male dormer and female dormer are two full-time subtypes of dormer. Use the generalization relationship to describe full-time subtypes. And part-time subtypes are unstable. Use part-time subtypes to model objects that may change from subtype to subtype during their lifespan. For example, in a welfare system, there are two subtypes of client, employed client and unemployed client. Because a client might change from one to the other one, the two subtypes are part-time. And finally, the generalization piece. So you use the generalization relationship to model full-time subtypes. The relationship points from the subtype, that is a specialized class, to the most general type, that is generalized class. So in this example, internal class account is a generalized class, fund account and cash account are specialized class, and both of them are permanent. Fund account typically in most of the banks cannot be made a cash account, and vice versa. So why do you model generalizations in structured analysis? Well, largely to reduce redundancies in the requirements and to allow you to specify rules that extend into the future, right? So it helps in this helps in keeping everything sane, and plus also keeping a common ground across the organization. So how can you find information for finding generalizations? Well, ask leading questions during your interviews. Okay, typically you have been told not to ask leading questions, but in here you should be asking leading questions. So use the initial class diagram of classes drawn earlier as a guide for questions, right? Ask interviewees if any of the classes are variations on others. Review the system use case documentation, and anywhere in the documentation indicates that there is more than one kind of something, generalization may be indicated. What are the rules regarding generalization? The specialized class inherits all the attributes, operations, and relationships of the generalized class. The specialized class may have additional attributes, operations, and relationships beyond those inherited from the generalized class. The specialized class may have a unique polymorphic method for carrying out an operation it inherits from the generalized class. I hope all of you remember what is polymorphic method. And also, according to the UML, a specialized class may inherit from more than one generalized class. This is called multiple inheritance. Many organizations limit the use of multiple inheritance because it can lead to ambiguities. For example, if a specialized class inherits two methods for the same operation from two generalized classes, which one applies? Right? So check within your organization or your development documents, or ask your developers before using multiple inheritance, or establish a policy. Then you should model transient roles. Okay, so you model the part-time subtypes that you skipped over in the previous step. In the previous step, you just focused on the full-time subtypes. A transient role is a part-time subtype representing a role that an object may play at one time or another during its existence, but may not play at other times. Is it a state or a transient role? Well, you may be wondering if you can handle part-time subtypes as states on a state machine diagram. The answer is that, in fact, a part-time subtype can be modeled both ways, in the state machine diagrams as a state and on class diagrams as a transient role. Okay, so whenever things are in flux or whenever things are temporary, you can either model it as a class in the class diagram as a transient role, or you can treat it as a state in the state machine diagram. It's a question of what you want to communicate. That is the crux that you have to decide as a product manager. If you want to get across how the object changes in response to events, use the state diagram. Okay, if you want to communicate the rules that govern how an object acting in a given role is related to other objects, use the class diagram with transient roles. Let me give an example. So consider a case of an insurance claim. It is important to describe the life cycle of a case object as it goes from the initiated state through its intermediate states and all the way to the paid and not payable in response to events and conditions. Correct? The state machine diagram explains this best. On the other hand, it is not important to explain how a case object's relationships to other classes change based on its evolving states. So there is little value in treating these states as transient roles in the structural model, right? So the situation is different for a participant object. Here, there isn't much to be gained by explaining the life cycle of a participant object as he or she changes from being in the state, let's say, in a as a member to a peace committee member, since the events that cause these changes are fairly self-evident, right? For example, a participant becomes a peace committee member by joining a peace committee. Very simple. For that reason, a state machine diagram of a participant adds little value. However, it is important to nail down exactly how the various participant object roles, such as, let's say, a Lions Club member or a peace committee member, attendee, and so on, are related to other classes, such as the case, the peace committee, the peace gathering, and so on. And this is best explained by including these roles in the class diagrams. I hope this makes things very clear that you need to identify what matters for the object in hand. Like for in most organizations, when an employee joins a certain organization, how the employee became an employee is not so relevant. The entire journey is not so relevant, but what is the relationship of this employee with the rest of the organization, with the tasks that he is supposed to do, and so on, is very important. So in that case, modeling the employee as a in the structural as a structural part uh, makes much more sense. Also, how does a transient role differ from a specialization? Well, an object's specialization cannot change during its lifetime, while an object's transient role may. So objects of a specialized class inherit properties from the generalized class. Inheritance does not apply, however, to transient roles. So why would you model transient roles? Well, the developers need to know whether the subtyping you indicate is full-time, this is generalization, or part-time, that is a transient role. Different design and coding solutions apply in each case. The only people who really know how stable the relationship is are the users. And as their representative, you are in the best position to find this out. Also, by indicating a subtype as a transient role rather than as a specialization, you are signaling to yourself that you need to follow up with extra questions that do not apply to specializations like multiplicity, etc. So, what are the rules about transient roles? Well, it is possible for objects of the primary class to have more than one transient role at a time. An object may change its transient role during its lifetime. And finally, by indicating that the primary class plays a role, you are not specifying that every object of the primary class has to play this role, only that it might do so. So, what are some of the interview questions that you can ask for determining transient roles? You can ask something like, can an object wear many hats? If the answer is yes, each hat is a transient role. For example, can an employee have more than one role in the organization? If so, create a new class for each transient role and draw a place role relationship between the primary class and the roles. Another question that you can ask is, can an object of a given class change its subtype during its lifespan? If the answer is yes, the subtype is a transient role. So, for example, any person in the peace committee organization may change from being a peace committee member to a peace committee to from a member of CPP, which is another committee that exists, to a peace committee member. So these are considered transient roles of person. Let's talk about whole part relationships, which is a very important part of the structured analysis. So some objects consist of other objects. In object oriented, you model these relationships using aggregation and composite aggregation. The whole truth. Well, aggregation and composite aggregation describe the relationship between a whole and its parts. Aggregation is the more general term. It just means that there is some kind of whole part relationship. Composite aggregation is more specific. It means that the whole owns the part entirely. The part may not belong simultaneously to any other whole. Use the following guidelines to decide which of these relationships to use. If a part can belong to more than one whole and the part continues to exist when the whole is destroyed, model the relationship as aggregation. Words that suggest aggregation include collection, list, and group. If a part is totally owned by the whole and the part ceases to exist when the whole is destroyed, model the relationship as composite aggregation. Keep in mind, however, that even in composite aggregation, a part can be preserved if it is detached and saved before the whole is destroyed. Words that suggest composite aggregation include composed of and component. And if you're not sure, just specify aggregation. What are some of the examples of whole part relationships? Well, the relationship between a catalog and the products that it includes is aggregation. On the other hand, the relationship between the catalog and the catalog line items that refer to these products is composite aggregation, because if the catalog is discontinued, so are its line items. The relationship between a travel booking and its flight, hotel, and car rental reservations is composite aggregation as well, since the cancellation of a booking also removes its reservations. And why you should indicate uh, whole part relationships? Well, aggregation is a strategy for reuse. If the same kind of part is used in more than one whole, the requirements for the parts class only needs to be written once. Later, if requirements for the part changes, they need to be specified only once to apply throughout the project. These relationships also help the product manager to distinguish between properties that are important for the whole and properties that are relevant to the parts. For example, in a mechanic's garage system, requirements that apply to a vehicle might include the attribute assembly date and the rule that each vehicle may be owned by one or more owners. Requirements that apply to vehicles part might include the attributes replacement date and part number. So how far should you decompose a whole into its parts, because it could be endless, right? Well, take things as far as the business requires. For example, a used car lot might have only a vehicle class to describe its inventory, whereas a service garage might require a vehicle class as well as a vehicle component class. The difference is that only the service garage needs to keep track of the components of a vehicle, so which is a very good indicator that what does the business need to need to track at the moment, and using that you can divide the whole into its parts. So what are some of the sources of information for finding aggregation and composite aggregation? Well, like most answers, I will say conduct interviews with stakeholders. Base your interview questions on the list of classes you compiled in the previous steps. A guide to question is right here. So you can also discover whole part relationships by reviewing screens, reports, layouts, and so on. Parts are often displayed along with the whole to which they belong. Also, review the system use case descriptions. If you discover any reference to parts, part attributes, or business operations related to parts, including the parts in the model, for example, a system for an auto repair shop may include a system use case service vehicle that refers to the next inspection dates for various parts of an automobile. So, what are some of the rules regarding aggregation and composite aggregation? Well, parts do not inherit attributes, operations, or relationships from the whole or vice versa. This is an important thing. Okay, the parts will not inherit the attributes or operations. Aggregation and composite aggregation do not employ full-time links between the objects. The whole can drop or add parts during its lifetime. If a part dies, then when the whole dies, model the relationship between them as a composite aggregation. For example, the relationship between a policy and the riders attached to a policy is a composite aggregation relationship. Specify any other whole part relationship for which the preceding role does not apply as aggregation. Don't lose too much sleep or over whether a whole part relationship is aggregation or composite aggregation. If you're not sure, just specify aggregation and you're good to go. And how do you show aggregation and composition? Simply draw lines between the components, indicating that the parts are connected, right? The numbers in the diagram, in fact, in the diagram that I've shared in the slide, the number 2 and the number 1 indicate multiplicities. Okay, we'll be covering that in a later section. I have mentioned some of the interview questions which are there in the speaker notes. I'll suggest that you have a look at that. Once you have done all of this, it's about time that you start analyzing the associations, right? And that is needed because you need to discover all the remaining ways that the system tracks one class of business objects against another. Each of these relationships is called an association. What are some of the examples of association? When information about one object refers to information about another object. For example, invoice data refers to product information such as description and price. So invoice is associated with product. To carry out a business operation relating to one object, an operation relating to another object must be performed. For example, when a booking is cancelled, an operation of booking, flights must be updated to reflect the newly available seat. Booking is thus associated with flight. And why do you need to indicate association? Well, too many reasons to point out, but let me mention a couple of them. Um, First, associations become part of the user's contract with the developers in a way, ensuring that the software supports the business requirements to link business objects. If you miss out on these associations and all of these things, then the software might be built without the real or the proper linkages. Secondly, the modeling of associations is a necessary preliminary step towards getting more detailed requirements, which is known as multiplicities, which we are covering in a separate slide. Finally, associations are an important input for design. In the design phase, associations implemented both in the code as pointers and in the database as foreign keys, right? Keep in mind though that they are not dictating to the developers how to design software. You are merely instructing them through the associations you model that the software needs to support the relationships. For example, that the software needs to track a case to the payments and made against it. And which begs the question, why isn't it the developer's job to find associations? Well, you can't know what the associations are without knowing the way the business works. For example, only the business side knows whether payments are made against individual bills or against an account. It is the PM's role, not the developers, to discover and document the rules that govern the business. What are some of the rules regarding associations? I think this is pretty self-explanatory and I've documented in the slide. I'll suggest to please go through the slide on your own time. Some of the important things to highlight though from this slide is, uh, so most associations are binary. So an object of one class is related to an object in a different class. So binary not in the sense of 1 0, but binary in the sense there are only two entities involved, right? For example, each case object is associated with a payments object. Associations may be reflexive. That is, object of the same class can be associated. That is, within a certain class, two objects are connected to each other. So one employee manages another employee, right? And you may name the association or you may choose not to name it. Naming is a good practice, but you can choose what you want to do, right? So moving along, it's very important that associations must reflect the business reality. That, I mean, it all sounds so easy, right? And it often is. However, be careful. Sometimes there are substitutes or subtleties. For example, in figure A shows a diagram modeling a system that manages credit card accounts. In figure A, a payment is made against an account, not against a bill. One consequence is that the system will not be able to track which bills have been paid and how much was paid on each bill. This may be adequate for credit card payments since they are not targeted to specific bills. Con- contrast this with uh, contrast this with figure A, which shows the model for a small business's accounts receivable system. While in figure B, the tracking of payments is more detailed. Each payment is linked to a specific bill or to specific bills. This type of tracking is usually required in accounts receivable system. Another important thing to understand is redundant association as a rule of thumb. So as a rule of thumb, if your model includes an indirect way to get from class A to class B and a shortcut that goes right from A to B, throw out the shortcut. Figure A illustrates this type of redundancy. In figure A, the associations that run along the top of the diagram requires a system to track all the invoices billed to a customer and for each invoice to track all the products appearing on it. This implies that the system is required to track the products purchased by each customer. The shortcut adds nothing new, so it is removed. What is the exception to the rule of thumb? Don't throw out the shortcut if it adds a new rule. So figure B is a good example of that. In figure B, the top path requires that the system tracks all of the sales made by a salesperson, and for each sale, the customer to whom it was billed. This implies that the system is required to track all the customers to whom a salesperson has made sales. But that's not what the shortcut says. It requires the system to associate salespeople and the customers for whom they are the prime contact. This is not the same as the first rule. For example, a salesperson may make sales to customers for whom he or she is not the prime contact, perhaps because the prime contact was away that day. As well, a salesperson may be the prime contact for a customer yet not have made any sales to that customer, perhaps because the customer was only recently assigned to the salesperson. Since the two rules are distinct, the shortcut is retained. How do you model object links with object diagrams? Well, sometimes you can get an idea across better by diagramming connection between object rather than a connection between classes. So for example, suppose you wanted to show that a transfer is debited from from an account and credited to a to account. You could show the requirement using classes and associations as shown in figure A. Right? There's a transfer which is debited to account and from account, and the transfer credited to the same account. Correct? However, since from account and to account belong to the same class but play quite different roles, it might be clearer to diagram the business rules as shown in figure B. Because the diagram in figure B shows objects rather than classes, it is not a class diagram but another UML structure diagram called an object diagram. Don't get too mixed up in all these diagram names and stuff, but essentially, as you can see, this is a very commonsensical approach, that if the class is the same, it will be very difficult or it might confuse people. So simply use objects to create a much cleaner diagram, right? So in this object diagram, that is the figure B, you can see each of the terms within the boxes are actually objects, right? And the relationship between the objects is referred as a link as opposed to an association which relates classes. So always remember that the associations always relate classes and not objects, right? So I'll just repeat once again. Use an object diagram instead of a class diagram if the situation you are trying to describe involves two objects that belong to the same class but act in different roles. So how to discover associations? Well, during system use case scenarios, interviews, look out for statements of the form X verb Y, where X and Y represent business objects. For example, quality team supervises the insurance claim. Quality team is associated with claim. The association name is supervisors. You conduct interviews focused on associations using existing class diagrams, examine the screens, report layouts, and so on, and that will give you a good sense. Also, look out for redundant associations. Use the rule of thumb which I shared earlier. And if there's a fine point about an association that you can't get across with the notations you have learned, just add a note to explain the issue and attach it to the association. It's not so high and dry. There are some more examples that I've shared um, in the speaker notes. I'll suggest please have a look. Let's talk about multiplicity. So in this step, you model business rules that deal with the number of business objects that may be linked to each other. Multiplicity is an indication of the number of objects that may participate in a transient role, association, aggregation, or composite aggregation. Okay. What is an example of multiplicity? It might be easier to comprehend. So in the insurance claim, each case object generates zero or more payment objects, right? Each payment object is generated by one and only one case object. So there's only one case object, and there is uh, but there can be multiple payment objects, correct? Because uh, a particular case may produce a zero payment object, and at the same time it may also generate multiple payment objects depending on the criteria fulfilled. So why indicate multiplicity? If you don't specify multiplicity, the software may not support important business rules, such as the number of customers who can co-own an account or the number of beneficiaries who can be listed for an insurance policy. Correct? Rules regarding multiplicity, well, I've so you can indicate the multiplicity at every tip of every UML symbol, indicating a transient role, association, aggregation. There are some ways in which you can represent multiplicity, like you can see in the diagram. There's one dot dot star, which basically means one or more. Uh, and on the right side, you can see account, where there is a multiplicity of zero dot dot star, which basically means zero or more. As you can imagine, this you can simply write this down also, just use text instead of all the symbols. But the idea here is that you need to understand that multiplicity is an important aspect, and you should be representing it properly on your diagrams. What are the sources of information for finding multiplicity? Again, you go back to interviews. Okay, you conduct an interview using all your existing class diagrams as source documents. The interview is over when you have answered all the following questions, and I've mentioned a whole bunch of um questions in the speaker notes, right? And the style of these questions are: to consider one object belonging to class A, what is the minimum number of class B objects to which it could be tied? And the common answers are 0 and 1, right? And similarly, the other questions. That's the broad template in which you should be asking questions. So let me just take a moment to do a quick recap and tell you the next steps. Well, at this point, your structural model, after you've gone through this entire exercise, behavior and structural model, so at this point, your structural model identifies the classes of objects that are used within the business domain as well as the business rules dictating the relationship between them. You also have documented some system use cases, a result of the behavioral model going on prior to and concurrently with the structural modeling. So this is a good time to consider the issue of traceability between the behavioral and structural model. That how do you link these two things? You should be able to trace or link any system use case to elements of the structural model, because the structural model contains details that apply to the use case but are not explicitly mentioned in it. For example, data validation rules, right? So the upcoming steps will walk you through this. Next, you'll be adding detail to your structural model by documenting rules about the attributes and operations related to each class, right? So how each class should be behaving, what are the rules, what are the attributes, and so on. By adding each rule to the structural model, you are giving it one centralized place to reside in the documentation, ensuring it will be consistently applied. You will also learn to carry out this step in the next few topics. Once the structural model has been set up, make sure that you actively use it. Every time a system use case is added or revised, check to see if those changes are consistent with the structural model and resolve any differences. Uh, a common question that I'm asked is: does the product manager need to put every attribute and operation in the structural model? Well, no. So focus on elements and that have the broadest application, and that, if not included in the model, carry a risk that they will not be implemented properly in the solution, right? So some guidelines to help you make that judgment call. So what is the lifespan of the software and how stable are the requirements? If the software is to be short-lived or the business requirements are deemed to be fairly stable, you lose some of the benefits of structural modeling, reduce time to identify and make changes to the business requirements documentation, right? Such cases would lean you towards doing less structural modeling. But let's say if the software is going to be bought off the shelf, if so, concentrate on high priority attributes and operations, because you would want the off the shelf software to be working properly for you. And of course, you also look at how much time do you realistically have. If you haven't been given enough time to do a complete model, I'll say concentrate on the high priority attributes and operations, and then just go ahead. So let's understand, how do we link system use cases to the structural model. So first of all, how do you find the modeling elements involved in a system use case? You look for nouns that represent categories of business objects such as customer, invoice. These are often classes. Next, pick out the verbs linking these nouns. For example, a salesperson makes a sale. These are often the relationships, right? How to document the links between system use cases and the structural model? Well, include all classes that participate in the system use case. If any of the classes are part of an inheritance hierarchy, describe the related generalizations and specializations in the diagram or add another diagrams depicting them. You can simply write instead of using diagrams, you can also just simply write. But in my opinion, creating diagrams would be much more clearer, right? And linking will help you, you know, make sure that the reader or the consumer of your document is able to connect the dots between the structural model and the use case. And you also want to make sure, a very important manifestation of this entire exercise is When you have use cases and the structural model connected to each other, when the use case changes, it will also tell you what structural model should be changed. Okay. So once you have done the previous exercise, now you can find out and document the attributes that are kept by the business for each class, right? So an attribute is essentially an item of information about an object that is tracked by the business. An attribute is specified at the class level. All objects of that class have the same attributes, but the value of the attributes may differ from object to object. Why do you want to integrate attributes? Because attributes are part of the user's contract with the developers. If you miss an attribute in your model, you run the risk that the system will not track that attribute itself, right? And later on, when you want to input, you will not have any data. You will not have any historical data, right? Another reason to indicate attributes is that you then have a place in your model to essentially hang the rules about each attribute, such as valid ranges and other verifications, right? What about verification rules about the attributes? They belong to the system use case documentation or not? Well, in general, no. The best place to put an attribute rule is right in the structural model and not in the use case documentation. Okay, since it gives the rule greater scope. The class diagram in the object oriented model apply across the board. On the other hand, if a rule applies to the attribute only within the context of a specific system use case, include the rule with the system use case documentation. Yet another option for documenting these rules uh, uh, is along with the screens that are developed to handle the GUI or the graphical user interface for the system use case. Use this option if the rule only applies whenever the screen is used but does not apply across the board, right? Uh, Screens are typically not considered an artifact um as they relate to the solution design, but you may request the designer to add in the rules you have identified, right? So once again, I'll suggest use the class diagram as a guide and then inspect the existing system use cases for references to attributes. Look for nouns, look for verbs, and that should give you a good indicator. Please refer the speaker notes as well as this slide to get a better sense. What are the rules for assigning attributes? That's the next thing to understand. So you should be checking each candidate attribute to ensure that it isn't already listed as a class. Next, take care to assign the attribute to the right class. The attribute should describe a property of objects in the class. Also, the attribute should be property that the system tracks individually for each object in the class. I mean, if you're not bothered about the color of your car, or let's say bothered about color of certain furniture, then you should not be even tracking it. So that attribute should not be there. It is just collecting dust. List an attribute as far up an inheritance hierarchy as possible. For aggregations and compositions, take care to differentiate between an attribute that is related to the whole and attribute that is tracked at the part level, right? And then attributes that the business tracks about an object regardless of the role are listed with the primary class. Okay. There's something called a derived attribute. A derived attribute is one whose values can be derived in more than one way from the model. If an attribute can be derived from other attributes in the model, either do not include it or document it as a derived attribute. So you mark a derived attribute with a slash. That's the typical convention. For example, it's just slash forward slash extended price. The documentation for a derived attribute should explain how the attribute value is determined from other aspects of the model. For example, extended price is a derived attribute of an invoice line item that can be calculated from other attributes as follows. So extended price equals unit price into quantity, correct? So unit price is an attribute, quantity is an attribute, and then you have a extended attribute called extended price. So why is it important for the PM to indicate which attributes are derived? Well, derived attributes can lead to data integrity problems if they pass unnoticed from the requirements into the database design. For example, consider a student final average that can be derived directly by querying a final mark attribute and indirectly by calculating it from the student's individual marks. Since there are two ways to derive this mark, there is always a possibility that they will yield different results. One solution, referred to as like normalization, prevents the problem by eliminating the final mark attribute entirely from the model. If there is no duplication, there is no inconsistency. Eliminating the redundancy also means less storage requirement, since the final mark attribute of each student is no longer kept on file but is recalculated as needed. On the other hand, this recalculation uses up system resources at runtime. The decision on how to handle a derived attribute is up to the database designer, but for that person to do his or her job properly, a PM needs to clearly mark which attributes are derived and how they are derived. So how do you indicate attributes in the UML? In UML, you will typically use a, a rectangular box like this, and you'll create a box, and you'll just keep it below the class name, right? So as you can see in this figure, peace committee is the class. Within that class, there's a peace committee name, there's a date founded, and the number of members. So you can see the number of members to be a derived attribute. The empty box below this is a operations. It's used to indicate operations, right? So so basically, these operations are those operations that can be done on the attributes. Okay, once you've added the attributes and their rules to classes in the structural model, ideally you should remove these details anywhere they appear in the system use cases, so that there's consistency in a single place. There's a single source of truth. But there are some companies who prefer to keep the rules in system use cases itself and not with structural model. You have to take that pick. I recommend to keep it with the structural model itself. Then there is something called meta attributes. So a meta attribute is an attribute of an attribute, which is a fancy way of referring to the verification rules and other properties of an attribute. So to document an attribute fully, you need to describe its meta attributes, like attribute type, multiplicity, the default value, and so on. Right? These are examples of meta attributes. You also learn to document that an attribute is derived by indicating a slash before its name, right? So slash extended price. So similarly, uh, that is a good meta attribute. For example, uh, unique is another interesting thing that you might want to track about a certain object, whether the object is unique or not. So a yes indicates that the value of the attribute is unique for each object in the class. For example, invoice number is always unique, but some other document, for example a solution file, may not be so unique. So in other words, no two objects may have the same value for this attribute. Range of acceptable values such as quantity on hand, invoice date, etc. List of acceptable values. So gender values are male and female, or male and female, or unspecified, and so on. However, if the list of acceptable values is subject to change, define the whole attribute as a lookup table. Then the accuracy of calculation. For example, if you're doing a financial app or financial product, you'll typically expect a very high accuracy, or anything concerning health, you would expect a very strong accuracy, right? What is the length? What are the dependencies? And you can just go on. But essentially, these are the meta attributes of an attribute. I just mentioned lookup tables. So a lookup table is a file that lists the allowable values of an attribute. For example, the drop down of states. Why do you want to analyze lookup tables? Very simply because uh, they will simplify any future modifications to the system, because for each lookup table that you identify, the developers will create data entry screens to add, change, and delete standardized codes, right? So using this, you'll get a dashboard at the back end where the change and where the data points can be changed in the lookup table. There are a couple of challenge questions in the speaker notes. I will recommend that you check that out. The next point is, how do we add operations? So far we have understood attributes and how to specify them, how to indicate them, and so on. Let's understand operations now, right? So recall that a class can handle or can hold both attributes and operations. You added attributes to the structural models classes in order to ensure that the rules for these attributes are treated consistently in the requirements. Also, by encapsulating attribute rules within the class's documentation, you created a self-contained unit of documentation that can be easily reused in other contexts. The same argument applies to the class's operations. On the other hand, while there is a good argument for modeling the operations of a class, in practice, few product managers actually currently carry out this step. Let me give an example. The insurance claim use case has a business rule stating that whenever a withdrawal from cash pushes the current balance below a certain minimum, which is a trigger point, a notice must be sent to the admin requesting new cash funds. This requirement now resides in the disburse payments use case. But what if this rule about the cash account must be applied to all other systems that withdraw from this account? Your solution is to add the operation withdraw funds to the cash account class. You attach the rule about sending a notice to the admin to this operation. In the future, any PM documenting requirements for any of the system that involves the cash account will be able to include the cash account class documentation that you created, ensuring consistent handling of withdrawals and other cash account rules. Right? The As discussed earlier, the generally preferred approach is to remove the rule from the system use case once it's been added to the structural model in order to avoid duplication. Right? So once you have added uh, the rule in the system use in the structural model, then you should be removing it from the system use case so that there's no duplication and the data is consistent across. At one extreme, this would mean removing the entire alternate flow describing the low cash balance situation. However, this may place too heavy a burden on the reader, in particular a stakeholder from the business side not accustomed to to this sort of cross referencing. A workable solution is to keep the alternate flow conditions but refer the reader to the cash account class for details on the system's response to the condition. Right? For example, you can just mention that payment causes a withdrawal from cash that pushes balance below a specified trigger point. The system responds as described in the withdrawal operation of the cash fund specifications, and you can see the structural model. Refer the speaker notes because I have mentioned this in speaker notes if you're finding it hard to follow uh, in the audio. By doing this, it will allow you to clearly describe the condition that is checked while leaving the documentation of the response in one place. Right? If uh, even this degree of cross referencing is too much for your readers, then update the withdraw operation in the cash fund class, but leave the entire rule in place. Right? This at least gives you a single place to return to when writing other use cases that involves the cash account so that you can verify that withdrawals are consistently handled. As a last step, make a final review of the model and revise if necessary. You may need to add some generalizations and drop some others. Okay. What are some of the rules for reviewing structure? You look for any class that has the same association to other classes. Consider adding a generalized class for them, for example. Look for any classes that have the same attributes or operations as other classes. Again, consider adding a generalized class and so on. There are some challenge questions and some more details of these rules. I'll suggest just please go through them in the speaker notes and the slide yourself. So this brings to conclusion of step 2 of how do you model. We went from discovery to defining classes, to defining attributes, to defining operations, and understanding what kind of rules exist. I understand that this might be too heavy or might look very theoretical, uh, but treat this unit as a reference unit. So as you go along and you start building your PRDs and your system documentations, you will be referring back to these units again and again. And only on once or twice of references, you'll get the gist of, or you'll be able to internalize a lot of these learnings that you have in this unit. Perhaps in the first iteration, you will get a hold of attributes and classes. That is structural modeling. And maybe the next iteration, you will understand a little better how use cases should be modeled, right? And that is perfectly normal. So that's it for now. Take care.